Well, hi, good morning, and thanks for joining me here in my shop for a little bit of a different video today. This is just an introduction to what you're going to see in this video, which I actually shot yesterday afternoon. So I was out puttering around my house and I suddenly thought, hey, the output transformer, you know, I never ever ohmed it out. I never got out my ohm meter and just double checked by taking some ohm meter readings in the output transformer, which is sitting right here. So that's what you're going to see, and I'm not going to say too much more, but other than this is this video where I will make a point of reading the comments on this video. And so I'm really looking for a way out of the situation that has developed here. I won't say any more, but here you go. Remember, this was yesterday. So I've just jumped in my shop here with an idea in the afternoon. Sometimes I get test ideas and stuff during the day. Of course, I run in my shop and try them out if they're simple. Excuse me. This one's pretty simple. I ohmed out the output transformer by measuring the resistance of each of the two windings, or two legs, or whatever you want to call it. I never actually tried right across the whole output transformer, just to see if the two numbers added. One was no, I'm going to forget now, 4,000 ohms, and the other one was 860, I believe. So there's my meter sitting here. Obviously something weird has happened because I've turned on the camera and started recording. I'm going to repeat what I did. Maybe you'll never see this piece of film. So it's between pins 3 and 4. 3 is the plate. 4 is the screen. So I'm doing one of the two output tubes. I'm getting 800, and that would probably be 65 or something like that. Same thing I got before. Now if I try reading right across from plate to plate, which should be just straight through the transformer, here's what I get. Ready? Megohm scale. Right across the plates. So you'd have to describe that as an open circuit. Well, so the one leg measured 860. Now I'm going to measure the other leg. 3 and 4, making absolutely sure I'm on 3 and 4. 3. That's the plate. That's definitely the plate. And 4. It's open. So, so that side that was 4,000, I thought was probably the correct side, and the 860 ohm side I thought had some shorted turns, and I began thinking of other possibilities. I'm trying to think what else could be wrong that maybe I'm just not thinking of. I thought maybe the wire going between the radio and the speaker might be involved in some weird way, but I really haven't done anything. Have I? Did I? So what I'm going to do, I'm going to use clip leads to connect this ohm meter to the reading, and find out if I wiggle something, maybe this is fixable. Maybe it's not at all what I thought it was. Let's see how good these are. Yeah, I don't know about these. Can't do that. Super reliable ones here. First I'll check to see that this is working. wait a minute. That was it. Wait, I should have some kind of magic trick going on there. That's more like it. First we'll try the one that works, or appears to work. I'm not going to clip it, I'm just going to push it on there. Okay, there we are. Okay. Let's put it right across the plates. I can't believe it. What's this saying? This is saying this thing was working and then it wasn't? And now it isn't, rather? What in heaven's name is going on? It's got to be some kind of intermittent thing. Could even be the plug down here. Even be the plug. Never had this kind of problem before. It's always the first time, so we're going to keep our eye on the meter for any jumping, anybody jumping. If it's going to happen, it's going to happen right away. Nobody jumped. Nobody. I can actually take this measurement up here. I can actually pull this out and repeat this measurement. I can figure out which wire is which. Just keeping hope alive here. These are the actual primary wires right here. Come on, this is quite a long shot, really. There's no skin off my nose to check, though. Well, let's see if we should be able to follow. So this is one of them. This is the plate, just from one tube. This is the plate from the other tube. Nothing happened, eh? Every time I put my hand forward, I block the light. There we go. Yeah. Same zero. Okay, speakers are fairly rugged in some respects. Let's just see if we can. Bring them around, man. Right on the winding. You know, if I'm going to do that, I would just squeeze it with my hand. There's some hope this would work. Some minor hope. No. Well, it looks like maybe the last time I operated this radio was the last time any voltage ever going to get to the second output tube. We got a push-pull now that's got all push and no pull. I can't believe this actually happened to the tube. The tube, doesn't matter what happened to the tube. The tube doesn't have to be in. Okay, I'm going to go mow the lawn. It's going to be an angry mow. And maybe some idea will come to my head. Some kind of suicidal idea or something like that. Okay, I got half the lawn cut and I got an idea. So my idea is this. Maybe the problem is here. I mean, I'd be lucky if the problem is here. Likelihood? No, but maybe. So what I know is that the voltage is getting to the center tap, getting through the center tap wire because it's coming back on one of the legs. So if there is a problem, the problem is on the other leg. And I happen to be able to see the wires. Yeah. So it would be this one right here. The light
the tan wire. Okay, tan wire. Tan wire. So it's just very remotely possible the wire is no longer making contact inside the prong. And the thing is, I'd be, kind of throwing out an output transformer or doing something here that I don't want to do unnecessarily if it's this simple thing. Come on over there. The tan wire. So I'm hoping I can get down to metal here with something tiny. Give me something tiny. This is pretty tiny. Oops, maybe. I'm going to contact the wire without contacting the prong. Have to bear off some of the wire somewhere. The wire's not exposed anywhere else, is it? No. Wait a minute. Something funny going on here. So this wire looks like one kind of wire with colors and stuff. When it gets on the other side of this chunk of tape here, the wires all look different. There's a joint inside here. There be a connection in there. I mean, there's every possibility that something has gone wrong inside the transformer, but I'm not about to just write it off like this. Does anything look out of sorts? Does it look overheated or burned up? Or no, it doesn't at all. So here we've got what look like two. So you see these two continue on up to this field coil. It's easy to guess that outside, and center tab. But look at these wires. And look at look how this is done here. This is supposed to be bent over a little nicer and come right around, and kind of. But look what it's done. It's actually cutting right in. It's cutting right in. It's cutting right in. We have to look in here. This is a lucky break. Something like this could put B+ on the right onto the speaker frame. Holy smokes! That's really deep in there. Wow. They've used friction tape, which is actually a pretty effective tape. Old timer tape. I'm gonna get this out of here without doing too much. I don't want to bend this further. There we go. It's not likely I can peel it off. And again, look at that, it's still flexible. Well, what are we going to find under here? Find out I have to go out and mow the lawn more. Okay, here we go. Okay, that separates these. These are not jointed. Why are these spliced? Is this not original? So I'm looking for any damage from where that jaw was biting on these. I don't see any. Now, can we tell? Yeah, we can. We can tell the outside from the center tab. Hey, these two are, just wrap these together. So, you know, I think lots of us would commonly do this. We individually insulate each wire, and then we put them together and then wrap them all up. This kind of reminds me of what I used to do at the power company I worked at. Only the splices I'd be cutting apart were a meter long, and you know, this big around. I'd be taking them apart because they blew up and trying to find out what had gone wrong. And most common thing, water entry. Where's my cutters? Water entry into the splice. It was in a manhole once. You know, manholes are dirty places and often full of water. You get the water pumped out. The crew pumps out the water. Nowadays they pump it into a truck and take it away. It used to just go down the sewer, and once the water's out, you go in. Because of my job in investigating cable failures, I was very concerned about going into a recently flooded manhole. Some of them had been flooded for maybe 10 years. No one had been in them till me. Something like that. Now there were other, you know, real cable splicing crews working, lots of them every day, and they just got used to the whole thing. But I was always kind of on guard because I was an office guy. This is lousy. I was kind of on guard every time I went in one. So I went in one in Toronto, downtown Toronto, after having it pumped out. First thing I would do is a quick inspection. I'm looking at these, you know, cables this big around, sometimes a dozen, sometimes more, laid around the walls of the manhole. The manhole is a concrete box, not much different in size from my shop here. So you look around quick, look for things like oil leaking out of the cable. That would tell you the metal, the lead cable sheath is cracked or burned open or something. You look for copper where you shouldn't see copper. That's scary business if you do, because that would mean a conductor's exposed. That would be very unusual. The unusual thing in this manhole was I looked at a cable splice. It was just a taped splice, just lots and lots of tape, just like this one, and it was all green. It was green all over the outside of it. So, being the guy I am, I grabbed my trusty voltmeter from the truck, brought it down one lead onto the neutral cable, and the other lead onto the green. As soon as I touched it, my meter went right up just as I expected it. 600 volts DC. So what I had right in front of me is a 600 volt feeder feeding streetcars. I was on Church Street in Toronto. The streetcar tracks there. And the 600 doesn't go to the tracks. Yeah. These unfortunately look good. Whoever did it did a nice job on it. Nicely taped and everything. So I'm doing the voltmeter thing, getting 600 volts DC. I'm thinking to myself, what if I put my hand, say, on the concrete wall, or, you know, on the wet floor, or just anywhere? There's all kinds of places to ground yourself in a power manhole, and then touch that green. Would I get 600 volts with enough current to kill me? Certainly, if I put my hand on it, I think I would die. So I'm staring at a killer splice. Well, why green? Well, because it's 600 volts positive. It's a DC cable sitting underwater. Tiny amounts of water getting in through various pores and other imperfections in the cable splice, and then a trickle of current coming out, carrying with it some copper copper ions, and then they're reacting when they get out oxygen or whatever it might be, copper chloride, copper sulfate, whatever it might turn into, and that's that green stuff. Oh my gosh, it's a kind of a direct connection right into the 600 volt conductor. Right after that, I organized an inspection of a whole pile of manholes with a similar type of cable in it, and we found another 8 or 10 of these killers, just waiting for somebody to brush up against it. I mean, who knows, right? I'm not about to test something like that. I did enough to convince me that it could kill people. So that's another one of my very, very proud moments in the work I did. So thanks for listening to that story. Unfortunately, the story here is, it's just no way these are broken. But it does give us more testing opportunities. Should I undo this one? I might as well undo. I gotta do it back up, so I might as well undo this one too. Now I need more story. See, I ended that story a little too quick. Yeah. Yeah, you can't do that kind of work for years and years and years and not get a whole bunch of stories. Unfortunately, some of them kind of close call stories and stuff like that. Not me. So I had my exciting moments, but almost killed me dead. The most dangerous thing I faced, and I think all workers doing this kind of work in manholes face in a big city, is automobile traffic. One of the other fellows working in the company, I didn't know him, he was working in the construction department, was killed one night by a Corvette. Corvette came down the road, went out to go around the cones, and then just swung right back in through another bunch of cones and pinned this poor guy up against the back of his truck. Killed him. Driver got out and ran for it. Hydro guys caught him, and he was drunk, and the car was rented. Isn't that sad? It is. You never know. You never know. You just never know. Yeah, another big danger in manholes is gas. Natural gas or from leaking gas pipes. Hey, okay, there's a story. Leaking gas pipes. City of Toronto, big city. At that time it was 1/6 what it is now. More than 500,000 people. You can picture what kind of gas distribution system would be in a city like that. These are all great. How many leaks did the gas company know of? They always knew of about 1,000 leaks in their pipes. They just granted many of them low priority, so they'll get to it someday. Can you believe that? 1,000 leaks. Of course. You can't believe the opposite, that it isn't leaking. Like a water main system, a good one, leaks 30% of its water. That's a good one. And a bad one can leak as much water as it serves to its customers. And where does it leak? It leaks through the ground into the sewer and disappears. Oh boy, really talkative here. Well, oh yeah, testing opportunities. Okay, back to work. Back to work. Leave memory lane and come back here. See if I can find a meter. Yes, things are a little relaxed on Jim's channel. That's more or less intentional. Okay, I got these big clips here. So I'll go on the center tap. I'm assuming. Hey. Well, we don't know exactly where these three wires go, but does one of them look a little different than the other two? Look. These two, well, whoever did this could have unwrapped them a little bit. Yeah, up here they all look the same. Yeah. I thought for a minute I was going to be able to identify the center tap and see that it's on the wrong wire. Yeah, wishful thinking. Okay, so we go from the center tap let's say this one. Nothing. How about this one? There's the 860. Boy, this just goes downhill, doesn't it? It's just getting worse and worse. And between them both, right across, right through that puppy transformer. She's dead, Jim. Okay, another squeeze play. Well, I can't milk anything out of it either. Okay, you know what this is time for now? Finish mowing the lawn. Okay, so it's back to today, the 13th, and I have one ace in the hole here to deal with this situation. I have another old speaker. I have one old speaker with a transformer on it. My options. This speaker's not in very good shape. I'm not too interested in the speaker. I'm interested in that. Can I stick that there? I hope the answer is yes, because this is really my only option that I know of. So I do have a way out of this. But I will be looking at the comments from this video. What I'm going to do with the radio in the meantime is carry on doing alignment work and stuff like that. I'll just disable the output circuitry completely, so there isn't any problem there. You shouldn't really run these radios with one tube operating in a push-pull. Okay, well thanks a lot, and yeah, okay, back to work here today. Wow.